Hello and welcome to Audi Service Training. Today we will be looking at the 1.6 and 2-litre 4-cylinder TDI engines as a modular diesel matrix, MDB. In the last programme on this topic, we looked at compliance with the EU5 standard. Today we'll be looking at compliance with the EU6 standard. From 2014, all newly registered vehicles must comply with this standard. Let's welcome our expert, Wolfgang Mattes from Audi Service Training.
Hello, Thomas.
The last programme dealt with the EU5 standard. Do you need to have watched that programme in order to understand today's programme?
Yes, because in that programme we talked about the engine mechanics and fundamental components. Today we'll be looking at the components that have changed for the EU6 standard.
So what are the differences?
First of all, the camshaft module is a variable camshaft. Another difference is that in the EU5 variant, there was a low-pressure exhaust gas recirculation system. The EU6 variant also features a high-pressure exhaust gas recirculation system. In addition, there is a combustion chamber pressure sensor with integrated glow plug, and then there is an NOx and sulfur storage catalytic converter.
So there are a lot of components. Where can viewers look up all this information?
SSP 608 also deals with this topic.
Let's start by looking at the changes to the cylinder head. What changes have been made to the cylinder head to comply with the EU6 standard?
On the cylinder head itself, there is the variable valve gear created via a camshaft adjustment. Inside, the cams are set up in exactly the same way as for the EU5 variant, only the camshaft adjuster has been added at the front. Here is the camshaft adjuster. Here we have the solenoid valve that actuates the control valve inside. And this here is the accumulator. So that you can see things a bit more clearly, I've manipulated the module.
Have we come across the camshaft adjuster before?
Yes, we know it from the control area in petrol engines. It's the same component on the diesel engine. Incidentally, the camshaft adjustment is being used for the first time here on the diesel engine. Here is the rotor on the camshaft adjuster. It has two chambers depending on where it is positioned. Here you can see the control valve. The solenoid valve pushes onto this valve from above to open up the channels. In this way, camshaft adjustment is subjected to oil pressure from the oil channel. That's how the camshaft adjustment works.
We have a diagram that illustrates this concept.
You can see the solenoid valve at the front, with the control valve behind. The camshaft adjuster is located near the rotor as a swivel motor. You can also see the accumulator, the piston, and the compression spring.
How does the accumulator work?
If there is enough oil pressure in the circuit, oil pressure acts on the accumulator. The accumulator pushes the springs together and is blocked by means of a retention valve. So oil pressure is always stored so that the rotor can be adjusted quickly. It's important that the camshaft adjustment happens quickly.
We have two graphics to illustrate this. What is the situation here?
Here we can see the filling process. The oil pressure in the oil supply is so high that the accumulator can be filled. At the same time, the camshaft adjustment is set too early. This means that it's in the start position when the engine is switched off. A locking bolt is engaged in the module and remains in this position when the engine is started. Once the engine is running and there is sufficient oil pressure, the bolt releases automatically.
We have another graphic.
Now the valve is supplied from above. The adjustment should now move to the late position. It's always at early, and the camshaft adjustment moves to the late position. The solenoid valve is energized. The accumulator supports the camshaft adjustment, so it quickly moves to the late position. In the same way, the accumulator supports the movement to the early position.
Let's take another look at the camshaft adjustment.
We've turned the engine. On the third cylinder, you can see that the inlet valves move in the same direction or not at all, or only one moves. Let me simulate that. Normally there would be a cover on this to ensure it is oil tight, but then we wouldn't be able to see. Let's look at the two inlet valves on the third cylinder.
Hier dritter Zylinder, Einlassventil, das sind diese beiden. Ja, diese beiden.
I'll move the camshaft adjuster. You can see that when moving from the early to the late position, one of the valves moves. Now it has moved to the early position, so the valve is pushed down. So one valve opens while the other is still closed. If the engine now continues to turn, the closed valve is open for longer once it has opened.
But you don't want this effect if you want more power. You don't want the valve to stay open for longer.
No, if you want more power, you need to play with the outlet valve in the same way. This produces a better fill level and an improved flushing process. However, by keeping the valve open, aspirated gas returns to the outside. This occurs after reaching bottom dead center when the compression actually starts. So the compression changes. This in turn reduces the pressure and the temperature in the combustion chamber. In this way, the amount of nitrogen oxide is reduced.
But in the full load range, power is lacking?
That's why the system is only used in the partial load range at low power. The vehicle rolls, or rather you accelerate, in the lower speed range. The system can be used to optimum effect in this case. At full load, the camshaft moves to the early position. Both valves open and close to the same extent, meaning you have full power again.
The graphic here also relates to the partial load range.
In the right-hand section under 3, it reads Inlet Variable Closing. As demonstrated, this means that one valve opens at an earlier point and the other later. And conversely, one closes at an earlier point and the other later. After reaching bottom dead center, it goes a long way out. The piston moves up again and pushes the aspirated gases to the outside.
We have a short animation about this.
This is the normal state. Both valves open at the same time. In this case, the rear inlet valve opened at an earlier point. As a longer channel is created, a swirl is produced. We looked at the swirl phases in the first part of the program. The other valve follows at full stroke so that a stronger swirl is created. When the piston moves up again, the valve that opened later stays open for longer. As such, the aspirated gases are pushed out again.
That was one part of complying with the EU6 standard. Now we come to the other part, exhaust gas recirculation. A high-pressure exhaust gas recirculation system is required to comply with the EU6 standard. What is that exactly?
The engine is based on the EU5 variant. This engine is supplemented with the high-pressure exhaust gas recirculation system. This system is required to quickly bring the storage catalytic converter to operating temperature. Here we can see the components. From the exhaust manifold, the exhaust gases flow directly into a bore. This bore passes through the cylinder head. The exhaust gases then flow into a high-pressure exhaust gas recirculation valve. This conveys the hot exhaust gases to the charge air cooler in the common rail. Thus, all the cylinders are supplied with hot exhaust gas. This gas flows directly into the combustion chamber. As a result of the hot exhaust gases, the combustion temperature rises briefly. This allows the catalytic converter to start quickly.
But all this only works when the engine is cold.
Yes, when the engine is started for the first time. The hot exhaust gases cause the temperature to increase and enable the catalytic converter to start quickly. As such, the amount of contaminants is reduced at an early stage, a prerequisite for the EU6 standard.
Is this another sensor here?
This pressure sensor is required to comply with the EU6 standard. There's a degree of variation in the compression. This compression can be checked using the sensor. Less filling means lower compression and a lower combustion temperature. So there is less nitrogen oxide. You can check this using the sensor. In addition, the camshaft sensor retains the position of the camshaft. In other words, there are two tools for checking the camshaft adjustment.
So there is a basic engine and different peripheral equipment for different EU standards. The SSP contains an overview of the current EU standards and the measures taken.
The EU4 exhaust gas standard was discussed in the first part of the program. In this case, simple components are built onto the engine for countries outside Europe. The EU5 is currently the measure of all things in Europe. That's why there is a low-pressure exhaust gas recirculation system in the EU5 class. An uncooled exhaust gas recirculation valve sits directly on the exhaust gas recirculation cooler. In addition, the exhaust gas recirculation cooler is installed for the EU5. The EU6 variant features all the components for the EU5. On top of that, there is the high-pressure exhaust gas recirculation system and a cooled exhaust gas recirculation valve. There is also the exhaust gas recirculation cooler, plus the NOx and sulfur storage catalytic converter, and the pressure sensor we've just mentioned.
There is another standard, EU6 Heavy Duty.
The vehicles are classified according to weight in inertia weight classes. In the case of EU6 Heavy Duty, the vehicles may have a different front, a different drag coefficient. They offer more air resistance and are heavier than the normal A3, for example. These vehicles also feature the SCR system with AdBlue.
Then we come to the most stringent standard at the moment.
That's the BIN 5 or ULEV in the US. It includes everything from the EU6 heavy-duty standard. That means that each cylinder is also provided with its own combustion chamber pressure sensor. There is also a sensor at the cooler outlet. This sensor measures the temperature of the coolant after leaving the cooler.
Thank you, Wolfgang, for explaining everything. You can read all about this in SSP 608. Thank you for watching. Goodbye. See you soon.